Okay, so this is the last technique of integration, which is integration by decomposition into partial fraction. Okay, so why do we use partial fraction? So if let's say we do end up with a rational function where in our denominator we have something like a quadratic, so we can actually decompose them into two linear and then we can integrate them directly. So this is the reason why we are using partial fraction, to make it easier for us to integrate them. Okay, so rational function, we can actually separate them into two, proper and improper. So we are only going to do partial fraction for proper only. If you have improper fraction, do make sure you do the long division to change it into proper before we can do partial fraction. So in partial fraction, we can have distinct linear, repeated linear, as well as irreducible quadratic. So this is a quadratic that cannot be factorized. For example, x squared plus 1 or x squared plus 2x plus with 3. So we cannot factorize them because we don't want any complex number. So that is why we call them a quadratic that cannot be factorized. Repeated linear, you might have x squared or x minus 1 with a square. So those are repeated linear. Distinct linear, x minus 1, x plus 2, and so on. So the power is 1. So we call them distinct linear. Okay, so let's go straight away to the first example. So we have 2x plus 3 over x squared minus 9. So do check the highest power for our numerator is 1. The highest power for our denominator is 2. So this is the case for a proper fraction. Okay, so check proper or improper. We have checked previously and I know this is a proper fraction. So that means I can straight away start with the partial fraction. So second step, factorize the denominator. So firstly, we start with 2x plus 3 over x squared minus 9. So factorize our denominator completely. We can see that that is equal to x plus 3 as well as x minus 3. So that is the second step. So the third step, we have to write the partial fraction. So now x plus 3, x minus 3, this is known as distinct linear because we have two different linear. So this is distinct linear. So that means we're going to use constant on top of here. Okay, so this is a over x plus 3 plus with b over x minus 3. And so this is the third step. The fourth step, multiply with denominator. So we have 2x plus 3 over x squared minus 9 on our left hand side. So everything needs to multiply with x minus 9. So 2x plus 3 over x squared minus 9 multiply with x squared minus 9. So cancel out. We have 2x plus 3 equal to, so we have a over x plus 3. X squared minus 9 is x plus 3, x minus 3. So cancel out x plus 3. I'm going to have a multiply with x minus 3 plus with b. So I have b over x minus 3 multiply with x plus 3, x minus 3. Cancel out. We're going to have b multiply with x plus 3. So that is already the fourth step. Let's go to the fifth step. So solve the coefficient. So let's write down what we have previously. So we have 2x plus 3 equal to a, x minus 3, plus with b, x plus 3. Okay, so there are two methods to solve the coefficient. You can use substitution, or you can use comparing coefficient. So both method actually works just fine. So just choose something that is much more comfortable for you. So since this is the first example, let me do both of them for you first. Okay, so let me start by using substitution. Okay, so let x equal to, so if you are using substitution, do make sure you refer to your zeros. So from the previous fraction, I can see that the zeros here is -3, the zeros here is 3. So I'm going to substitute with -3 and 3. Okay, so if let's say I let x equal to -3, then I have 2 -3 plus 3 equal to a -3 -3 plus with b -3 plus with 3. So this is -6 plus with 3, so we got -3 equal to a multiplied with -6. -3 plus 3 is 0. So a is equal to -3 over -6, so a is equal to half. And then substitute the second value, let x equal to 3. So 2 multiplied with 3 plus 3 equal to a, 3 minus 3 plus with b, 3 plus 3. So this is 9 equal to b multiplied with 6. So we got b equal to 9 over 6, which means b is equal to 3 over 2. So we already have both value now. So this is by substitution. Of course, you can use comparing coefficient as well. So to use comparing coefficient, you got to expand them a little bit. So 2x plus 3 equal to ax minus 3a plus bx plus 3b. So make sure you simplify a little bit. So a plus b, x minus 3b, 3a plus 3b. So this is 2x plus 3. Okay, so by comparing coefficient, so we can see that for x to the power of 0, let us choose the constant. So we have 3 equal to -3a plus 3b. So if you divide everything by 3, 1 is equal to -a plus b. So this is the first equation. For x to the power of 1, on the left hand side, I have 2. Simply take the coefficient without the x. So 2 is equal to a plus with b. So this is the second equation. So first equation, second equation. So if I add these two, if I do 1 plus with 2, 1 plus 2 is equal to 3. -a plus a is 0. b plus b is 2b. So I know that b must be 3 over 2. So go back and substitute. So we know that a plus with 3 over 2 must be equal to 2, which means a must be equal to half. Okay, so if you check a equal to half, b is 3 over 2. So we do get the same answer for both of them. Okay, so don't forget, do write down 2x plus 3. Your question again, 2x plus 3, x squared minus 9. So this is equal to 1 over 2 over x plus 3 plus with 3 over 2 over x minus 3. So this is our partial fraction. Okay, so let us go to the last step. So we have to write in integrand form and integrate. So copy down the question. So we have 2x plus 3, right? Okay. So 2x plus 3. Integrating 2x plus 3, x squared minus 9 dx. So I already changed this into partial fraction, where I have half over x plus 3 plus with 3 over 2 over x minus 3 dx. So let me separate this into 2 first. So I'm going to have integrating half over x plus 3 dx plus integrate 3 over 2 over x minus 3 dx. So since we have some constant up here, let us bring them out. So half 1 over x plus 3 dx plus 3 over 2 integrate 1 over x minus 3 dx. So integrating 1 over x plus 3, so this is half ln x plus 3 plus with 3 over 2 ln x minus 3 and then plus with c.